Percentage yield. In this video we are going to be looking at percentage yield. By definition, percentage yield is the ratio of the actual yield to the theoretical yield multiplied by 100%. What are we talking about here? This is still chemistry under more concept, where we try to calculate the percentage yield that is likely to be obtained from the chemical experiment. Now, what are we trying to show when we are being examined on percentage yield? When we are doing an experiment, we understand that we use the reagents. And when we calculate the amount of the reagents to react, we actually discover the amount of products that are likely to be produced from the experiment. That unexpected amount of substance is what we call the actual yield. And the one which is calculated from the equation is what we call the theoretical yield. Now, we express this value as a percentage. That's the reason why we need to understand when we say yield. What does it mean? Yield is the amount of product produced when substance reacts. Amount of products. What you get out of the reaction is what we call the yield. Now, when we say actual yield, what does it mean? Actual yield is the amount of product obtained at the end of the reaction. What we are going to get at the end of the reaction is what we call the actual yield. The actual yield is also known as experimental yield. Very, very important. Why is it also known as experimental? Because we get that amount of the products after performing an experiment. Theoretical yield. Theoretical yield is the maximum amount of the product calculated from the measured amount of a given reactant using the balanced chemical equation and the Mohr concept. So we are going to calculate the maximum amount of the product expected to be obtained from the chemical reaction. Therefore, we are saying theoretical yield is also known as expected. What you expect to get from the experiment. Therefore, it is also known as expected yield. Take note, the actual yield is usually less than the theoretical yield due to the following factors. There are factors that can affect the amount of the products that are being produced. Okay? Meaning what we calculate from the experiment, that is factual as compared to what we are going to get from performing an experiment due to the certain factors. The first factor is that the reactants may fail to react completely due to the presence of impurities in them. So the first factor is the presence of impurities in the reactants. We understand certain impurities affect the chemical reaction to go to completion. The second one is that the reaction may be reversible, such that some of the products formed are converted back into the reactants, preventing the reaction from going to completion. Reversible reaction. We form the product, again the product recombines to form reactants. That will affect the amount of the products expected. So this is another factor. The factor number 3 is that there may be evaporation of both reactants and the products for the reaction that involves volatile chemicals. When we say volatile chemicals, we are talking about those chemicals that are able to evaporate. Okay. Now, we are interested in calculations. This question number 1, I am not going to solve this question because it is very simple. I am going to solve question 2. Because when I solve question 2, I understand you can solve question 1 on your own. But I'm going to help you to analyze it. Consider the reaction below. They have given us benzene reacting with chlorine to form what we call chlorobenzene, this substance here, plus hydrogen chloride. When 36.8 grams of benzene react with an excess of chlorine, the actual yield of chlorobenzene is 38.80 grams, meaning they have given us what we call the actual yield, which is 38.80 grams. Find the percentage yield of the chlorobenzene, this substance here. What is the percentage yield? So in whatever you are going to do, you are not supposed to include or to use 38.80 grams in your calculations. In short, in whichever question you are given under percentage yield, the actual yield is not involved in your calculation. Make sure that you just keep it as for you to come and use it when we are calculating the percentage yield. Point number 2. This question is simple because they are saying excess chlorine, meaning the limiting reagent is benzene, because they are saying chlorine was in excess. And remember, my dear learners, I emphasized that when you are doing calculations, every time use the limiting reagent, because the limiting reagent is the one which is going to determine the amount of products that are going to be produced. Why? Because this limiting reagent finishes before the other reagent does. So you need to understand that. So in this case, you are going to be using benzene. You pair benzene with the chlorobenzene. You are going to use more ratio. Or if you want, you can use mass ratio, since they have given you the amount of benzene in mass, 36.80 grams. So you will find the mass of chlorobenzene, and when you find that mass, you are going to record it as the theoretical yield because you have just calculated it. So that is very, very important, as we are going to observe in my calculations in example number 2. Another important point you need to understand is that it's not every time that the percentage yield will be dealing with the reagents or products given using masses. No, sometimes the volume can be given to you. So if the volume is given to you, it means now you are dealing with the gas. For example, if they wanted to calculate this, the amount of hydrogen chloride, maybe they would have given you the percentage yield of hydrogen chloride in form of the volume. Again, the procedure will be the same. So you need to understand that, my dear learners. Understand that as you are going to observe in the example. So I expect you to answer this question, and immediately we meet in the class, I will demand for the books to see how you are going to solve this question. Question number 1 under percentage yield. Excuse me. So let us look at question 2. I am interested in this question. As you can see, it has a lot of sub questions from it. The question reads, 5 grams of calcium carbonate was reacted with 40 centimeter cubic of 2.75 moles per decimeter cubic of hydrochloric acid, according to the reaction below. So you can see the reaction and the products being formed like that. If 1.1 decimeter cubic of carbon dioxide gas measured at RTP was collected in a graduated gas jar. Remember, we know how to find the volume at RTP and standard temperature and pressure, that is STP. So, they are saying if 1.1 decimeter cubic of carbon dioxide was measured, meaning this was experimental, therefore our actual yield is 1.1 decimeter cubic. At no point should be this value be used when we are doing calculations. You just keep it for the final calculation of percentage yield. Now, this question is tricky because we don't know the limiting reagent between calcium carbonate and hydrochloric acid. So that should be the first step. Okay? For you to know which reagent is going to determine the amount of carbon dioxide that is going to be produced, you need to determine the limiting reagent. Failure to which, it just know that you are going to fail to calculate the question. Now we can look at the questions. Question A reads, state the practical yield of carbon dioxide. This question is very simple. Practical yield is the actual yield. So the answer for A solutions, the answer for A is 1.1 decimeter cubic. This is actually the volume. That is practical. State which reagent was in excess. You have seen? So they want you to calculate which reagent was in excess. Remember, my dear learners, that we are now dealing with B. We are going to calculate this from the chemical equation calcium carbonate reacting with HCl to form calcium chloride plus water plus carbon dioxide. Okay? Now, between the two, which one is the reagent in excess? Remember, they have given us the volume and the concentration of hydrochloric acid. Therefore, since we have the volume and the concentration of hydrochloric acid, it's possible that we can calculate the number of moles. Let us calculate the number of moles of hydrochloric acid that reacted. Here they have given us the mass. The mass here is 5 grams. Again, here we are going to find the mass, the number of moles of carbon dioxide that reacted. I think it's better we start with the first reagent, calcium carbonate. So this one is easier. Number of moles equals mass over molar mass. So number of moles equals mass is 5 grams over the molar mass of calcium carbonate is 100 grams per mole, where the number of moles now will be 0.05 moles. We have calculated here. We come to hydrochloric acid. They have given us 40 centimeter cubic. So we are going to say number of moles here equals CV. Number of moles equals, the concentration given is 2.75 mole per decimeter cubic, which will be multiplied by, you know that the volume should be in decimeter cubic, so we need to convert that 40 centimeter cubic to decimeter cubic by dividing it by actually 1000. So when you divide 40 by 1000, you get 0.04. This will be decimeter cubic. This will be decimeter cubic because of space, or let me work smartly. Like that, where this and this will go. So number of moles equals, we'll find that it will be 0.11 mole. Now, you know how we find the limiting reagent. The actual number of moles are now divided by the stoichiometric number of moles, or stoichiometric coefficient of the reagents from the chemical equation. So when we look at this, we'll see that calcium carbonate, when we look at the stoichiometric equation, the coefficient of calcium carbonate is 1. So we are going to say reagent calcium carbonate will get the number of moles 0.05 moles divided by 1, and the answer will be the same, 0.05 moles. Okay, we want now to come and compare. Remember, we just compare one mole. The mole ratio should be 1 to 1. That's the reason why we divide by the stoichiometric coefficient. And then we'll say reagent HCl equals, we calculated 0.11 mole. Now the coefficient of HCl, there's a 2, so divide by 2, so that we can find the number of moles of just one chlorine molecule. Okay, since we have 2 moles, what is the number of moles of 1? So we'll compare 1 to 1, not 1 to 2. So we are going to say, when we divide here, it will be 0.06 moles. So here we have hydrochloric acid 0.06 and the calcium carbonate 0.05 moles, where we are going to say this is greater than this. And remember, the reagent with less number of moles becomes a limiting reagent. The one with a lot of moles is the reagent in excess. So the question was demanding us to calculate, to find out between the two which one is a reagent in excess. So to answer that question, we are going to say HCl is a reagent in excess. C. What is C demanding us to do? State which reagent was a limiting reactant. We have calculated there that the one with less number of moles is a limiting reactant, which is calcium carbonate. So here we are going to say calcium carbonate. Of course, you write in weights and you put the values in brackets, the symbol, the chemical formulas in brackets. So this is a limiting reagent because it has less number of moles. It has less number of moles. Again, I need to advise you on how to treat this number of moles. The number of moles at this point, this number of moles and this number of moles here. We just use this to pick which one is a limiting reagent and which one is the reagent in excess. But when we are doing calculation, we use actual number of moles, which is 0.11 and 0.05, because these are the reagents which are there provided to react. Okay. And remember to use a limiting reagent when we are doing calculations. So we go to D, calculate the theoretical yield. Okay, my dear learners, this is going to be very simple. I think I can delete this because you'll be able to pause the video when you want to copy. But as at now, I am going to clear it so that I can be nearby the questions. Okay, so calculate the theoretical yield. The theoretical yield is actually the yield which is obtained by doing some calculations. So I am going to pair what I am looking for with a limiting reagent. A limiting reagent is calcium carbonate. I'll pair it with carbon dioxide. We are looking for carbon dioxide. Now, when we look at mole ratio, here we have 1 mole and here we have 1 mole. So here the mole is more to 1 mole. And the number of moles of calcium carbonate that reacted was 0.05 moles. There you say X. When you calculate the number of moles here, you will find that here it will be 1 mole, it will be X mole. This times this, it will be mole X equals 0.05, this is 5 mole squared over mole over mole. So X equals mole and the 2 will go the same value. This is of carbon dioxide. So we have calculated the number of moles of carbon dioxide that was produced from the reaction, and this number of moles was collected at RTP, room temperature and pressure. And remember, at room temperature and pressure, if we have 1 mole occupies the volume of 24 decimeter cubic per mole. Remember, we did the molar volume, so I don't expect you people to be facing challenges. This is what 1 mole is going to occupy. Now, what will be the, this is molar volume actually. This is molar volume. Molar volume. Now, what will be the volume if we have 0.05 moles of carbon dioxide, since 1 mole can occupy 24 decimeter cubic? So this is what we are going to do. We are going to say volume equals number of moles times molar volume. Volume equals number of moles 0.05 moles times the molar volume is 24 decimeter cubic per mole. So mole and mole will go, volume equals, you will find that the volume is going to be 1.2 decimeter cubic. This becomes the theoretical yield. So this is nothing else but the theoretical yield. So you need to understand that. So we have calculated, we have the practical or the actual yield, and we have calculated the theoretical yield. I think the last question now will demand us to calculate the percentage yield. Let us check. E is saying calculate the percentage yield. This is the last question. So how is the percentage yield going to be? So you are going to say percentage yield equals actual yield over theoretical yield times 100%. This was the definition. This was the definition. So there was an important point which was given, that every time the actual yield is less than the theoretical yield, because the actual yield is affected by a lot of factors which we listed. Okay. So now, remember my dear learners that the actual yield was given to be 1 0.1 decimeter cubic, and what we have calculated just now is 1.2 decimeter cubic. This is times 100%. So our percentage yield will be now equal to 91.67% of carbon dioxide. This is how we move. We are calculating from the chemical equation. When that equation is given, between the two reactants given, one will be a limiting reagent and the other one will be the reagent in excess. When we are doing calculations, every time use the limiting reagent, because when the limiting reagent finishes, the reaction will be over, meaning that that is the reagent that is going to determine the amount of products that are going to be formed. So take your time, follow the steps so that you can answer question number 1, because that one is just simple. You just find the mass, which will be the theoretical yield, and then the actual yield is given to you. Then you convert that to percentage. That will be very, very important, and I'll be excited if at all when I demand for the books, I find that you manage to calculate. Thank you so much once more. In as much as you learn, remember to revise. Revise to be wise, otherwise no rise. Thank you so much.